These are notes from Elham's Math 251, section 2.1. I've got the book page here and my notes here. Of course, you can't see it so well here. You're mostly getting the audio. Look at the notes that I've sent you on the attachments and you'll be able to see that better. So ideally, you look at what I sent you in the attachments and just kind of follow along with my audio. For 2.1, they give you this table. You're just essentially finding a lot of slopes. So for number 1a, you take the point 15 to 50 and then you plug in all of these others. So for instance, when it says t equals 5, you have 5 comma 694 and the point 15 comma 250. Do your formula for slope, y2 minus y1 divided by x2 minus x1. Same thing for all the others. So for 30, you'll be using 30 comma 0 with 15 comma 250. Find this formula for the slope. And B, estimate the slope of the tangent line by averaging two secant lines. So for instance, take the average that you got from 10, 444 and 15, 250 with 20, 111 and 15, 250. Part C requires you to graph it. So I plotted all these points on my little graph here. So the actual graph is in red and the tangent line is in green. So the tangent line just kind of grazes the line right across here. So this is what I came up with. What you have may not coincide exactly because we're just guesstimating here. That's the best we can do. Right? So the way I drew it, it comes out to be something like this. All right? So I got this point here, which appears to be 10 comma 700. Okay, plugged into the formula for the slope. So the m for the tangent line came out to be negative 30 gallons per minute. All right? So that's what I got in this particular case here. So 215 minus 700 over 15 minus 0, assuming that's the point 0 comma 700. Number 3, you have the function y equals 1 over 1 minus x at the point 2, negative 1. And they're giving you all these numbers to plug in. I decided to choose a couple of them. So for A, number 4 was 1.999. Plug in 1.999. I got negative 1.001001 repeating. Figured out the slope. y2 minus y1 divided by x2 minus x1. So negative 1.001001 minus a negative 1 divided by 1.999 minus 2. Came out to be 1.001 repeating. And then for part A8, I decided to plug in 2.001. So I was doing this one and this one. 2.001, plug that in. You get negative 0.999000 repeating. Throw that into the formula for the slope, y2 minus y1 divided by x2 minus x1. Negative 0.999000 repeating minus a negative 1 over 2.001 minus 2 comes out to be 0.999000 repeating. Okay, and you can do the same thing for all the other ones. The idea is to look for a pattern. If you look at this number and this number, well, it looks like it's very close to 1. So the estimate for the tangent slope is 1. So the slope of the tangent line is 1. And they say to use that to come up with the equation of the tangent line. I plug it into the point slope form. Y minus y1 equals m times x minus x1. You want to get comfortable with that. We're going to be using that quite a bit in this class. So y minus a negative 1 equals 1 times x minus 2. And you can finish the rest of that. Okay, number 5, I didn't really do anything except write down the formula. 40t minus 16t squared. Let me just tell you what's happening for that one. Now it says from t equals 2 and lasting for so many seconds. So if it lasts until, or lasting 0.5 seconds for number 1, that means you're going from 2 to 2.5. And for part 2, when it says lasting 0.1 seconds, you're plugging in 2 and 2.1. And let's say the last one, lasting for 0.01 seconds, you're plugging in 2 and 2.01. So your x coordinates are 2 and 2.01. The y coordinates you plug in and then go from there. So you're supposed to see if there's a pattern and use that pattern to estimate what happens at time t equals 2. Okay, and then 7, average velocity, same thing. So for instance, 2 and 4. From 2 to 4, you're using 2 comma 20.6, 4 comma 79.2. Plug it into the formula for the slope. That's the average velocity. Okay, let's say for the third one, average velocity from 4 to 5, you're using 4 comma 79.2 and 5 comma 124.8. Use y2 minus y1 divided by x2 minus x1 to estimate the average velocity. For instantaneous velocity when t equals 3, again, that's the slope of the tangent line, so you have to use the graph. So I took all these points, I graphed it. So the red is the graph. The tangent line is the green. Yours may not exactly coincide with mine. That's okay. So I have it looking like that. Okay, and then I tried to find the slope of the tangent line. So right here looks like I got about 1.8, 1.8 comma 0. How did I get that? Just from the graph. And 3 comma 46.5, which is right off the graph. So use the formula y2 minus y1 divided by x2 minus x1, and it comes out to be about 38.75 feet per second. That would be considered the instantaneous rate of change of the function right at the time t equals 3. Right, so these are notes for 2.1.